Each horse at a ranch eats 20 pounds of hay each day. Complete the table to show how much pounds of hay there are per horse. This is a typo. All right, so remember, we are not looking at the relationship here. We are looking at the relationship between number of horses and hay in pounds. So you ask yourself, all right, well, what do I do to 1 to get 20? Well, I multiplied it by 20. 1 times 20 is 20. So I'm going to do that here. I'm going to take 2 and times it by 20. So 2 times 20 is 40. And we might as well jump over to the 6 horses. So if we know we have 6 horses and each horse eats 20 pounds, I know I'm going to take 6 and multiply it by 20. And that's 120 pounds of hay. Now, we have a vice versa situation. Okay, we start out with 60 pounds of hay. How many horses will that feed? Well, we have to work backwards. So we're going to divide by 20. So 60 divided by 20 is 3. Same thing, 80 divided by 20 is 4. 100 divided by 20 is 5. 140 divided by 20 is 7. Okay? So there's our table, and our table will help us with answering questions about horses and pounds of hay. So the first question says this: what is the unit rate for pounds of hay to horses? Okay, so we're looking for pounds of hay over horses. Now remember, to find the unit rate, we have to have 1 on the bottom. So if I go through, this right here represents horses. So here's 1 horse. So if I look at this, there it is. So my unit rate is 20. 20 pounds of hay for 1 horse. C, when a group of ratios are equivalent, that means that they have a proportional relationship between the 2 quantities. Okay? Is there a proportional relationship between pounds of hay eaten daily and the number of horses? Explain. Yes, there is. Here's why. So we have 20 to 1. That is equivalent to 40 to 2, because if I were to reduce 40 over 2 down, it's 20 over 1. That is equivalent to 60 over 3, which is equivalent to 80 over 4, which is equivalent to 100 over 5. And if I kept going and going and going, all of these are equivalent ratios. They all have a unit rate of 20. And because they do, that is why they are proportional, as the Buddy, the Cake Boss guy, would say. Proportion, proportion, proportion. Okay? So, moving forward, let's take a look at this problem. Tessa plays her favorite song several times. It takes 16 minutes to play it 4 times. Bam! There's our rate. 16 minutes to 4 times. Complete the table to find how many minutes it takes Tessa to play the song the different number of times. All right? Well, we're going to start with the first one because this is the easy one. So if she doesn't listen to her song 0 minutes, that means that she hasn't played her song at all. So 0, 0. And like we already talked about in the last section, you have to have 0, 0 no matter what if you want a proportional relationship. Now, let's go down to this one. This is the data that they gave us. 4 times she played her song, and it took 16 minutes. So you ask, what do you do to 4 to make it 16? You multiplied it by 4. So therefore, let's fill in the rest, knowing that information right there. So 1 times 4 is 4. 3 times 4 is 12. Now this one says we listened to the song for 8 minutes. How many times did we play it? Well, we work backwards. We're not going to times it. We divide by 4. So it looks like we listened to it 2 times. Now, B, describe the relationship between the number of minutes Tess spends playing the song and the number of times she played it. So she spends 4 minutes playing the song 1 time. So she spends 4 minutes playing the song 1 time. C, once Tessa knows how many times she wants to play the song, how can she find out how long it will take her? Well, we found this out, didn't we? So she would have to multiply the song played, the number it was played, by 4. Okay. And then finally, we're going to write an equation, right? So we're going to write it for how many minutes Tessa plays the song T times. Well, you guys, we just figured this part out. So she multiplied the song by 4. So 4 times the song played, right, equals the minutes, the total minutes. So I wrote that out in words. Now let's write it out with our variables. So we know that songs played is T for time. So it's 4T. Notice I don't have to have a multiplication sign in between there, because when you put a number next to a variable, that automatically means multiplication. When I see the equal word, I put in my equal sign, and then minutes is going to be replaced with an M. So our equation is M equals 4T. Congratulations, you guys just wrote out an equation from a table. All right, so now that we have a little bit of that under our belts and we can fill in a table based on the information that was given to us, now we're actually going to take it a step further. So here's what we've done so far. We completed a table, we found what the unit rate was, and we wrote an equation. Whew, we've been busy. So look at number 1. Okay, all right, the table shows how many gallons of water that it uses for showers of different number of minutes. All right, so if we look at this right here, it looks like if she spends 1 minute in the shower, she's using 2 gallons of gas. I hope she's not showering in gas. Woo! How about 2 gallons of water? For 2 minutes, she's using 4 gallons. 3 minutes, 6 gallons, 4 minutes, 8 gallons, 5 minutes, and so on and so on. All right, so the first thing that I want you to do is let's kind of find the relationship between minutes and gallons of water. So again, I'm not looking at 2, 4, 6, 8, 10, 12. I'm looking for the relationship that these two quantities have. Okay, so if I asked you, what do you do to 1 to get 2? I'm hoping that you're going to say, oh, you multiply it by 2, Mrs. Parkin. Well, let's see if that works for the rest of them. 2 times 2 is 4. Yep. 3 times 2 is 6. All right, cool. So if we take a look at all of these, I'm hoping that we have a proportional relationship. That brings us to A. How does the table show a proportional relationship between the length in time and the number of gallons of water used. Okay, so how does the relationship between length and the number of gallons? Well, if you look, okay, here's the first one. This is minutes and this is gallons, 1/2. Guess what? That is equal to 2/4, which is equal to 3/6. So they have equivalent ratios. And because they have equivalent ratios, I know that there is a proportional relationship. Now B, what is the unit rate, and this is where it gets tricky, of gallons of water per minute? So this is a little different. This is gallons per minute. So we rewrote that. Okay, we flip-flopped it. We did the reciprocal of it. Now remember, our unit rate has to have a 1 as the denominator. So if we go up here, we're going to go to minutes and we're going to find 1. There's 1 right there. And if we go down to how many gallons of water, it's 2. So our unit rate is 2 gallons per 1 minute. That is our unit rate. Okay. Now, we're doing one more step ahead. When ratios are equivalent, they all have the same unit rate. So look, up here, our unit rate was times 2, times 2, times 2, times 2, times 2. That is actually called the constant of proportionality. So all unit rates are actually called constants of proportionalities. So if I asked you, what's your constant? You're going to tell me what the unit rate is. Or vice versa. If I said, what's the unit rate? You're going to give me the constant. All right, those are the same thing. So what is the constant of proportionality for the relationship of gallons of water to minutes? 2. Same thing as this. Same thing that we saw all the way across here, 2. The only difference is the unit rate. We're going to actually write it out of gallons per 1 minute, where the constant, you can just say 2, and that's it. So now we're going to use the constant of proportionality to write an equation that shows the number of gallons of water, G, during M minutes. Okay, well, look at this. Here's what we found out. We took our minutes and we multiplied it by 2, constant, to get the gallons, right? So if I took my minutes, 4, multiplied it by 2, that represents the gallons. So our gallons equal 2 times minutes. So in words, that's what we know. Now let's write our equation. Gallons of water is G. Equal is an equal sign. 2, and I don't have to put my time sign because I'm going to just put M. So this is your equation. Next, what is the unit rate? Ooh, look at this. This is different. What is the unit rate for minutes per gallon? So now we're flip-flopping it. We're doing minutes per gallon. So let's just look at the very first one. The first one we have our minutes is 1 to 2, right? Well, remember, okay, this doesn't have a denominator of 1, and we have to get it to 1. So 1 divided by 2 is 1/2. So here it is. So for every half minute, we use 1 gallon of water. And we can confirm that up here. If we have 1 minute for 2 gallons, if we go down to 1 gallon, right? Okay, it's a half a minute. So I just continued my table. So my unit rate is 1/2 minute per 1 gallon of water. F, what is the constant of proportionality? That should be a no-brainer, you guys, because I told you the constant is the unit rate. We just found our unit rate. So our constant is 1/2. Next, write an equation that shows the length of the shower in minutes based on using G gallons of water. Okay, so what we know is this. We know that our minutes equals 1/2 times the gallons of water, right? So here's your equation. M equals 1/2 G. There's your equation. Okay, so now, all right, this is where it gets interesting because we are going to apply everything that we've done into more of a complex problem. So there's a proportional relationship between the area of a wall and the amount of paint needed to cover it. So they're already telling us that there is a proportional relationship. So we don't have to find that. What is the constant of proportionality, aka unit rate, for the relationship? And then explain it. All right. So let's go through and just figure out what we have here. So if I want to cover 100 square feet, I need 1/4 gallon of paint. 200 square feet for 1/2 gallon, 300 square feet for 3/4 of a gallon, 400 square feet for 1 gallon, 500, and so on and so on and so on. Remember, okay, in order to find the unit rate, aka constant of proportionality, you're looking for the one that has a 1 as the bottom number. So if we go through, nope, that's not 1. Nope, that's not 1. Nope, that's not 1. Ding, 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 ding. Here it is right here. That is my constant of proportionality. That is my unit rate. So 400 square feet of wall for 1 gallon of paint. A lot of you guys picked this one right here just because it was first. Remember, this has to have a denominator of 1. All right. Now, use that constant of proportionality. Our constant of proportionality is 400. Notice, remember, the difference between unit rate and constant. This is the example of a unit rate. It's got labels. Our constant is just the number. We're going to use the constant of proportionality to write an equation that represents the square feet of wall W that can be covered by G gallons of paint. Well, let me ask you, what do you do to G to 1 to make it 400? We multiply it by 400, right? Well, look at this. Ready? Watch this. If I, just to prove to you, okay, 1/4 times 400, what do you know? It comes out to be 100. So these are all the same, I promise. So here's our equation. The square feet in wall, W, equals 400 times the gallons of paint. Because if I took any of these and multiplied it by 400, I would get that. Okay? All right, number 3. Do the table and the double number line. Do the table and the double number line show the same constant of proportionality? Okay, how can you tell? Well, to figure this out, what we're going to do is we're going to do cost over mugs for both of them. Cost over mugs. Okay, we're going to do that and find out what our constant of proportionality is. So this one is 8 over 1, 24 over 3, and 40 over 5. All of these reduce down to 8. Let's do this. 16 over 2, 32 over 4, 48 over 6. What do you know? All of them reduce down to 8. So the constants are equal. So that means that both of these are equal. Okay? That they are proportional with each other.